Hi, in this video we're going to find the volume of a prism where we have to find the area of the cross-section ourselves. Now just to remind you what a prism is, if I scroll back up, it's a 3D solid such that wherever you chop the solid, you see the same shape on the end. And you're going to see this particular shape here, and that is known as a cross-section. And we saw that the volume was equal to the area of this cross-section here multiplied by the length of the prism, which is here, right? So let's apply that formula to this problem. We need to find the area of this cross-section because wherever we chop this triangular prism, we're going to see that triangle, aren't we? And then we're going to times it by this length, which is here. So this is your A, the cross-sectional area, and this is your L, the length of the prism. So what is this area of the cross-section? Well, it's a triangle, isn't it? And the area of a triangle is half times base times height. So half times the base, which is 9, times by this height here of 8, and that is 36, and it'll be centimeters squared. But we don't need to worry about the unit until the end. And then we said that the volume was the cross-sectional area times by the length. So it is 36 centimeters squared times by the length of the prism. This was the length of the prism. It's the 5. And that is equal to 180. And what's a unit? Centimeters cubed. Volumes are always a unit cubed. So here it's centimeters cubed. So that's the final answer. It's 180 centimeters cubed. Right, we've got a second one here. This time the cross-section is a trapezium. And let's remind ourselves how we find the area of a trapezium. So if I got some lines like this, and let's just say that this is the pair of parallel sides here, the lines in the same direction. Then if the two parallel sides have lengths A and B, and the height between them, the distance between those parallel sides is h, then the area of this is going to be the average of the parallel side, so A plus B over 2, multiplied by that distance between them, perpendicular distance between them. So let's apply that to this problem here. Well, if that is 3 here, this is 3 here also, so let's put the 3 there. Now we can see that the parallel sides are here and here, so that is your A and your B. And then this height between them here is, we can see it's the 7, so we can just put the 7 there. Right, so now we can use our area formula. The area of the cross-section, which is a trapezium, is equal to, and we saw this formula, A plus B over 2. So 3 plus 8 over 2, multiplied by the distance between them, which is the 7. And I'm going to use my calculator for this, 11 divided by 2 times by 7, which is 38.5. So we've got 38.5. And now we said the volume of the prism was equal to the cross-sectional area, which was 38.5, the area of the trapezium, because the cross-section was a trapezium, multiplied by the length. We can see that this is the length of the prism. It's the 5. And so we times it by 5. And again, I'm going to need my calculator for this, 38.5 times by 5. And this is equal to 192.5. Now, because all the units here were in centimetres, the volume will be in centimetres cubed. So that is the final answer, is 192.5 centimetres cubed.